All right, so before we can talk about asynchronous JavaScript, we need to talk about how the internet actually works. So we're going to be learning a bit about HTTP, which is an acronym you've probably seen every day you've used the internet. So HTTP stands for Hypertext Transfer Protocol, and it's essentially the foundation for how the internet works as we know it. It was originally described in 1991 with the origins of hypertext dating back as early as 1930. So this is an early example of an HTTP protocol in action, the Pinball Expo 1994. So this is just a very early website created using hypertext. So this protocol was originally designed as a protocol for transmitting hypertext, and what hypertext is essentially the precursor to HTML now. HTML stands for Hypertext Markup Language. So hypertext in the original text was essentially just a way of just what was sent before we used HTML. And so now HTML has grown to support more than just linking from one page to another, but it was the concept of linked pages with HTTP protocol that made the early web possible. And it's also found new cases because transmitting hyper to HTML is a common use. It can also transfer any type of document or file. So HTML isn't even the most common type of document transmitted over HTTP, because now we send images, CSS, JavaScript, API responses, and everything else that goes on in the internet every single day. So the internet is essentially a series of conversations. So the HTTP protocol describes a conversation between two parties. One is the client, which is us, and one is the server, the computer you're trying to access. So the client sends an HTTP request, and the server sends an HTTP response in response to that. They're both plain text. They can easily be read by a human, and each one has a very simple structure. So whenever I see cartoons or something like that where someone goes into the internet and they visit a website, like it's a physical place, that's not actually true. Every time you visit a website, it's just an instance of a conversation happening between you and the server. So here are some examples of a very basic request with a very basic response. So this comes from us, from the browser, and this comes from the server we're trying to access. So here's the first line, which says get, in this case, /bio.html, HTTP 1.1. So we're going to take a look at this line by line. So get, first off, is the method we're using. There are a lot of HTTP methods out there, get being one of the more common ones. We're going to get to the other ones as we go through it. The second part is the URI, so the endpoint we're trying to reach. And then the protocol version, which in this case is version 1.1. So the most common HTTP verbs include get, which is when you want to retrieve a resource. Post, when you want to send a resource, so when you're creating something new and want it to be saved on the server side. Put is typically used for updating a resource. And delete is being used for deleting a resource. I'm going to pause here for questions for a bit. I know this is kind of a lot of information kind of dumped on you. Any questions about HTTP so far?
I guess just back on the previous slide, when you is the protocol version, is that when you're sending a request and you say /1.1, does that mean I'm ready to accept things in 1.1 format, or I'm submitting them? Like what's trying to do there?
Yeah, so you're saying what version of the protocol you're using, and I don't know, I've never heard of any instance of somebody going like, well, I'm on the wrong version of HTTP, sorry. So I don't know exactly whether or not this is something that can cause difficulties or anything like that. I think it's just part of the kind of the syntax, but I may be wrong. This is something to kind of explore on your own a bit.
I had a question. Since this is more or less plain text, can we assume that there's no actual it's not case sensitive? The capitalized get and the capitalized HTTP, that's more or less semantic for us to read it like, hey, big and bold, this is what we're trying to do? Or are those keywords that need to be capitalized when we use it?
I believe the case sensitivity isn't an issue. And spoilers, you're not going to have to write these yourself very often. One of our challenges today is going to see you making your own HTTP server, but after that, it's never something you're going to have to manipulate directly. I do believe it's mostly convention that has what's capitalized, though. All right, going to move on. So the next part of the request line is the URI, which is short for Uniform Resource Identifier. So you've probably heard the phrase URL before. URI is somewhat different. So the URI is essentially the endpoint. So, in this case, they have a host down here, example.com. And so the endpoint of the host is the /bio.html. So if you combine the host name with the URI, you get a URN, example.com/bio.html. And then when you add the protocol, HTTP, you get the URL. So oftentimes what you talk about as being a URL, you actually might be looking at a URN, because very often a lot of browsers won't actually display, you can type in a URN and your browser will still automatically convert it into a URL by adding the HTTP at the end. So honestly, I've never heard URN come up very much in conversation for development. It's mainly about URIs and URLs.
What do they stand for again?
So URI is Uniform Resource Identifier. I've forgotten what the L stands for in URLs, but Uniform Resource. Let me look this up.
Locator.
Thank you. Uniform Resource Locator. And URN would be Uniform Resource. One sec. Uniform Resource Name. Actually, I remember I saw an interview recently with one of the early kind of innovators of HTTP who actually said if he could go back, he would make it so that you wouldn't have to type in http:// every time you wanted to go to a website, but too late now. So after the request line, we have headers. Headers have additional information about the request. So this is the request line says we're making a GET request to this URI, and this is our protocol type. And the headers include, okay, what host we're actually going to, and the user agent. So the host is which server we're going to, example.com, and the user agent is who's asking. In this case, Google Chrome. And kind of bare minimum of a GET request is you need the request line and you need the headers. Then you can also add a body, which is optional. There's always a blank line between the headers and the body. And the body can include extra information with your request. It's like queries. So in this case, if you're going to a website and you want new red Jordans, you could say query equals new plus Jordans and color equals red. So that's extra information you can send the server to inform them what you want. Oh, and they've also added, you can also ask for specific types of content, as in what you're sending up to them. And you'll mainly see request bodies with post, put, patch, and delete requests. And they can include all types of content, including image uploads, form content, etc. So your body typically is going to be used for things like submitting forms, but it can also be used for search functions, for example. So these query params can also be added to the URI instead of being included in the request body. So an example here would be /search, and then they have a question mark. And the question mark is telling the request that, hey, we're looking for a specific thing. Query equals Air Jordans and color equals red. And individual query params are always separated with the and symbol and ampersand. So we're saying, after the question mark, it's saying, okay, we're going to a URI that ends with /search, and then we're also sending up these query params. So that's just another way of adding stuff to a request if you don't want to use the body. So if you ever go to like something like Amazon and type something into the search bar, I believe it should show you your query params up in the URL bar. We can even test that right now. I do, book. All right, so books is maybe a little bit, it's a larger category. So let's search for something a little more specific, like New Jordans. So instead of using query, they use something else, but you can see S, short for search, question mark saying, okay, what happening next is the query. Then K equals new plus Jordan, and then it's got and ref equals this. I'm not sure what this means in this particular case, but you can see this is what it's in action. So anytime I want to go back to the search page, I can just copy this complete URL, including the search params here. I could even add my own search params in the URL if I really wanted to make life difficult for myself. So, do rice plus cooker. And I've just essentially circumvented the search bar just because I felt like it.
Is there a difference between the plus and the modulo 20? I mean, does that represent the same thing?
Good question. I'm
The
not sure if there's
percent 20 is converting it. That's a hexadecimal number. It's converting it to decimal 32, which is the space character on the ASCII chart.
Ah, thank you. So yeah, so that you're right. So the modulo 20 there is saying air space Jordans, and air plus Jordans gives you a similar effect. It would just be saying I'm searching for the term air with the term Jordans in this case. All right, any other questions about query params and GET requests and everything like that? Okay. So headers, they provide additional context about the request. So examples we have here, so the host tells the web server which domain the client is requesting content from. A single web server can often serve content for multiple domains, which are sometimes called virtual hosts. The server uses this header to determine which content to serve. So you'll find, so essentially, it's not just enough to go to a particular server. We're telling the server we want to get this particular resource. You can also tell it to what language you're accepting. So accept language EN is saying, we want a response to be sent back in English. Not every website is going to have an option for other languages, but if it does, you can say accept language, and then every language has like a different short code. So if you want something back in Japanese or Arabic or what have you, you can tell it to say, I want a response in this language. The user agent is saying what kind of client sent this request, because sometimes the server will respond differently based on who the user agent is. So a request coming from your browser, from Google Chrome, may have a different response than one coming from, for example, your own website making an API request. And then finally, accept. It says what type of response it's interested in receiving. So if you're looking for a website, it'll typically be HTML, but you could also might be asking for an image or JSON data. Now let's talk about responses. So a response will first have a status line, then some more headers, then a blank line, and then optionally, but usually, a body. So the response status line has 3 parts. It'll have a status code and the reason phrase. So these are kind of linked to each other. The reason phrase just explains the status code. And a status code of 200 means everything's A-OK. And again, it's got the HTTP version. And there are many, many different status codes, some of which you have seen many times and other times you haven't. So 200 occurs every time something goes the way it's supposed to. 302, see other, is a redirect. 400 means a bad request, meaning that you formatted your request badly. 401, unauthorized, means you're not allowed to see the thing you're requesting. 404 means the thing you're looking for doesn't exist. And then 500 is just saying, hey, something's wrong with our server and we can't complete the request. And these are just kind of scratching the surface of status codes. These are the ones you'll see most often. There are dozens of other status codes out there. And they're also kind of divided up by first digit. So anything starting with a 2 means success. Anything starting with a 3 means it's a redirect of some kind. If it starts with a 4, it means that you, the user, have somehow messed up. So either you're not allowed to see the thing, or the thing doesn't exist, or just something is wrong with the way you formatted your request in the first place. And then anything starting with a 5 says the problem is on the server's side, saying, hey, something's wrong on our end, it's not your fault. The kind of headers in the response serve a similar purpose to the ones in the request. They provide additional context that the client uses to interpret the response. So for example, what content type it is, so that'll tell you what it is and how to parse it. So you'll often say text HTML, but it could be JSON or something else. It'll always tell you the content length in bytes, so how many bytes long the response body is. It'll have things like telling things to save a cookie with a particular name and value. And it'll also tell you when the response was sent. So whenever you visit a website on a typical page, it's not just one HTTP request and one HTTP response. It may be dozens or hundreds of conversations taking place, not simultaneously, but very, very quickly. So for example, getting the HTML, just the raw HTML, is one request and response. The CSS is another HTTP request and response, then the JavaScript. And then you might need another HTTP request and response per image on the page. So if you've ever noticed that, like, if your internet's really slow and you find yourself on a web page and you can see the page itself and it's styled, but all of the images are blank, and then they start slowly filling in one by one, that's why. It's literally making just your browser contacting the server and getting a request back, and contacting the server and getting a request back over and over again for every image on that page. Any questions? Taking a quick break for questions.
For instance, when we create the CSS file in the JS script, let's say hypothetically we're pushing on server, when somebody else requests that, they're downloading a copy of it and it gets stored in temporary, so that way they can kind of run the program. Okay.
Yeah, that's exactly what happens. That's why when on Monday, when I was having you manipulate the DOM of the specific websites, you weren't changing anything in the server. You were only changing the copy of the website that the server had sent to you. So a very important characteristic of HTTP is that every conversation shares no state. It's a stateless protocol. So every conversation between the server and the client begins a new connection. It's like they're meeting for the first time. So no matter how far apart they are, one request doesn't change. Like, one request has no knowledge of any other requests. So anything that's kind of has to be saved between them either has to be saved on the client side or the server side. Otherwise, there's nothing actually shared between them. So most servers clear all state variables with each request. That means all states when processing a request come from the request itself. So it's usually your browser or your website or what have you who's making the request. You're telling it to specifically ask for the right information every single time. So this is where cookies come in. So cookies and local storage help retain state, like who's logged in or what was their last search across multiple requests. And again, this might sound like it's a violation of the stateless nature of HTTP, but even with cookies, HTTP remains stateless. It's just how the cookies are implemented. So it's essentially saying when your browser holds onto a cookie, that's just telling your browser, here's some extra information to send up with the next HTTP request. But the HTTP request itself doesn't really remember anything compared to any other HTTP request. So server sets cookies by sending them to the client as part of the response. The client stores the cookies. The server never stores them. And any cookies for any current domain are sent to the server as part of the request. So you get cookies from the server, and then you send them back next time you visit. So HTTP is a proven protocol. It's extensible and has found uses far beyond what was imagined in 1991. It's simple, it's human readable, and easy to parse with code. It changed the world by connecting users and servers to form the web, but today it's the foundation of so much more. You'll realize very soon that HTTP is literally everywhere. Any other questions about HTTP? Okay. In that case, I'm going to stop sharing for now.